Smasho here, coming at you with the Daily Space Weather, a feature of the Smash News Network, least busted name in news, for which there is zero competition. Good luck covering the sun in the detail that we cover it daily on the channel. Thanks to all of our new and long-time viewers. We've got tons of filaments around the solar disk and a sunspot number nearly at 200. It's what you call active solar levels. So here's your northeastern limb, here's your northwestern limb. We've got a very high likelihood of X-class solar flares. NOAA is even suggesting the possibility of proton events. We'll cover it in a moment. We've also got a cosmic ray report coming for you today, and lots more. Here's your your southwestern limb, rather. The Hulk Hogan prominence here. The Hulk Hogan filament now becoming the Hulk Hogan prominence. We've also got the Patrick Stewart prominence, named yesterday on the Twitter feed. Here is your southeastern limb. And let's take a look at a full disk view here after this plays. There you go. That's 304 plus 193 angstroms. A great composite series of images from SDO, great at showing solar filaments, active regions, and the extended corona. Let's take a look at sunspots here. And wow, the likelihood of really large solar flares in the northwest is very, very high. We've got two very large, very magnetically complex sunspot groups setting right here. So yeah, I'd say the likelihood of an X flare here is higher than 50%. I would also note that this sunspot up here is at a very high latitude. Further indication that we've got a long way to go to reach solar maximum in solar cycle 25. As far as evolution of sunspots, we've got some major growth. Oh, that's a brand new group right there. That's just yesterday plus today. So we'll have a fairly stable sunspot number here. Despite some major group setting, we've got some major groups also forming. Let's take a look at it in colorized magnetogram. By the way, that's yesterday plus today. You can see the time and date stamps in the lower left. We may have some more active regions forming there in the southern hemisphere as well. The sun. It's certainly in an active state. So it's exciting stuff here. And let's move on to see what's going on Croissant Earth for a quick moment. I'm interested in what volcanoes are erupting. It turns out Subanose-jima is. It's producing a 4,000-foot volcanic ash plume. Kilauea's lava lakes, the Halema-Uma'u lava lake, the western and eastern, both appear to be filling. No overflows yet at Kilauea. Popocatépetl exploding in central Mexico, flight level 220. Fuego exploding in Guatemala, flight level 160. Revenador exploding in Ecuador, flight level 150. That's a 15,000-foot volcanic ash plume. Cotopaxi also exploding. No indication of the flight level there. And Sabancaya exploding in Peru, flight level 240. It's a 24,000-foot cone of volcanic ash over Peru. Next, we'll look at global seismicity here, and there is your 90-day bar graph conveniently curated by Volcano Discovery. And let's take a look at the USGS site. We'll cite any quakes larger than a 5.0 magnitude. So, of course, we are seeing aftershocks in Turkey continuing here. And Indonesia did see a 5.1. That was at 1738 Universal Time yesterday afternoon. Besides that, it's been quite calm here, so not a lot of quakes and certainly no major quakes. I think there was one over a 6 magnitude here. Just a minute. The Kuril Islands saw a 5.2. That's in between Kamchatka and Japan. And there we go. There was a 6.1 at New Zealand. Actually, that's like north of New Zealand there near the Kermadec Islands in the Kermadec Trench. I'll show the location of that real quick. There's the largest quake of the past 24. That 6.1 occurred at 9:18 Universal Time this morning on February 13th. Continuing up the list, And that is where it ends. By the way, please support the channel. Consider becoming a member of the Smash Team if you aren't already. SmashOnMash.com/Smash Team is our subscription services site. You can still support us via Patreon. Also, you can find all kinds of links to help the channel out below the video. Help yourself out, perhaps with some Hemp Lucid purchases. Right there, you can see the link again below the video as well in the description. SmashOnMash.com/Smash Team. You can find all of our links there. All kinds of social media, our Redbubble shops, all shown there, and lots more. So hit us up on the interwebs. Thanks to especially gold and silver Smash Team level members. There are also bronze memberships. The best value is the gold annual paid-up subscription. Today's featured product is the Tony Fauci Fraudster Face of Evil products. Now, right over here, I've got my foot on a Fauci Face of Evil bath mat right now. It's super plush, and it's great to be able to put your feet on the face of evil daily in the bathroom. I'm also wearing the shirt. Tony Fauci, Fraudster, Face of Evil. For some reason, the Face of Evil always feels the need to expose itself to you. And I guess you have to make a conscious choice to follow the ridiculous advice from the Face of Evil, believe the lies, etc. So perhaps this might make a great gift for your favorite Fauci fanboy or gal. The Fauci Face of Evil bath mat. It's a delight. It's great to put your clean face, your clean feet on the dirty face of evil when you step out of the shower. Again, it's very plush. It's like softer than velvet. That bath mat, by the way. And if you click the links below the video, you'll find our Redbubble shop in order of best selling. So lots of different products there for various different reasons. In fact, we even have one that's because reasons. So check that out, and let's get back to space with the last 24 hours in 304 angstroms from SDO. That's ionized helium. And thanks for leaving comments, Mr. Abordages. So this is the past 24 in 304 angstroms. Let's add 171 angstroms to add a little character. Some different features portrayed there. That's ionized iron. And let's get into some space weather stats. 10.7 centimeter radial flux, currently at 200 solar flux units. Solon.info features a one-year graph of the radial flux. It's this black line. And if you're paying attention, you can see how proportional that is to the red line, which is the sunspot number, which is just below 200. So the sunspot number is at 198 here at the moment. And if it does drop today because of those two groups setting in the west, it won't drop very much. It's not going to drop below, I'll say, 180. Space Weather Enthusiast dashboard is forecasting some possibilities of geomagnetic unrest here. Late in the day tomorrow, Valentine's Day, and early in the day on Wednesday the 15th. And if you read this little blurb here, it also says that there is a high possibility of X-class flares and proton events. So that's the Space Weather Enthusiast dashboard. Feel free to check it out on your own. And let's take a look at planet Earth's geomagnetism. The KP index is currently at 1.33. It's quite geomagnetically calm conditions indeed. We've got a great signal from the solar wind at the moment. Let's take a look at Earth's magnetic moment from space. Should be fairly unremarkable here. This is the last 4 hours of magnetohydrodynamic pressure. From two different planar views, the equatorial plane on the left, the meridional plane on the right. The right side depicts the Earth from the side, and the left side depicts the Earth from the top. Here is ground magnetic perturbations. Earth's magnetic moment from the ground. Should be the last 4 hours also. Again, things are quite calm here, geomagnetically speaking. And let's take a look at the solar wind for the past day. Pretty unremarkable here. We've seen a subsiding of the solar wind speed and a minor uptick in the solar wind density here. The fields are looking pretty weak. So the top frame there, the field is only 2 nanotesla with a BZ of -2, phi angle 122 degrees. The density there, just under 6.5 protons per cubic centimeter. Solar wind speed here, just over 350 kilometers per second. Those look like legit numbers to me. And let's look at some more data here. The GOES magnetometers showing higher readings than we expected. That was kind of a surprise there, as we forecasted lower readings today. Keep in mind the magnetic environment can change with basically no warning. And let's take a look at the heliospheric current sheet next. And welcome to the North Pole. The North heliospheric magnetic pole, depicted here in green. South Pole depicted over here in red. Most of the north polar magnetism here currently oriented toward Earth. Also, we are watching this North Pole coronal hole here, the one located around the heliographic North Pole. As it's not left yet, it's still kind of hanging out. So we still got significant magnetism at the North Solar Polar region, the North Heliographic Polar region, that is, as opposed to the Magnetic Polar region. And here's our line of sight field plot. Again, welcome to the North Heliospheric Magnetic Pole. Since a lot of that magnetism currently oriented toward the Earth. No, it's not going to kill you. It's a normal feature of solar cycle progression. Speaking of which, let's get to coronal holes, since we don't want the video to be too long. So here is your coronal hole line of sight plot. You can see all those green blobs there. Those are North Pole oriented coronal holes. And it looks like at the moment we've got just about 0 South Pole oriented coronal holes. Let's see what it looks like from SDO in 211 angstroms. So these are North Pole, North Pole. These are North Pole. These are North Pole. So again, welcome to the North Pole, the North Solar Magnetic Pole. You're currently there. And let's move to sunspots next. Keep in mind, high-speed solar wind emanates from those coronal holes. Those are solar radio jet locations. So sunspots here, and there are way more than I'm going to talk about, showing up as many as 14, 15 named sunspot groups here, possibly. So we'll have at least one more named group. It'll be this group right here. There may be a couple more little pores here opening, so we may actually see an uptick in the sunspot number today, but keep in mind we do see some massive groups setting here in the northwest. So here's a view of that. That's the last 24 hours in 304 angstroms plus SDO continuum. We'll zoom in a little bit closer here. And another place to watch besides the northwestern limb is this sunspot right here. As it's rapidly grown, it's gone from non-existent to very large and magnetically complex. And we've got a cosmic ray report coming here. First, the GOES proton flux, some minor little spikes there in the proton flux. Again, NOAA forecasting the possibility of spikes in the proton flux there. If we do see major flares, we could see some polar radio blackouts caused by those relativistic particles. At the moment, it's pretty flatlined. And we're going to get to solar flaring here in a moment. First, let's talk about Cygnus X3. Now, it's the only known cosmic ray point source. It was discovered in the early 1980s at an underground mine in Minnesota. They thought that Russians were setting off nukes every 4.8 hours, but that didn't seem very logical at all. And the important thing to notice about Cygnus X3, which is also the brightest intrinsic object visible from Earth, the star Deneb in the constellation Cygnus, is that we've seen an extended high X-ray state here. So Deneb is currently, or Cygnus X3 I should say, is currently in a high energy X-ray state. So if you look right here, you can see 0.05. 0.05 is way up here. And that is the longest period of time that we've ever seen, going all the way back to 2005, of Deneb being in that high energy state, except for maybe sometime in around 2012. But we do certainly see an extended high energy X-ray output there. Lots of X-ray counts from the supermassive X-ray binary. It features a Wolf-Rayet star being orbited by a denser, more compact object at very, very high speeds. Anyway, it's one of the only known cosmic ray point sources. If you want to read more about it, head to smashomash.com/forum. The Cosmology Forum features a thread only about Cygnus X3. Again, it is a massive X-ray binary. It's also the celestial pole star at the other end of Earth's precessional cycle. So feel free to read about that if you like. Lots of information there about Deneb on smashomash.com/forum. If you don't know how to find it, you can find links below the video to smashomash.com. Click on the forum, click on the Cosmology Forum. You'll see Deneb right in there. Probably the most interesting object in the Milky Way galaxy, at least from the perspective of our solar system. Again, it's the only known cosmic ray point source, and that has to do with the inability to determine where cosmic rays come from. This one, because of its X-ray signature, made it very obvious that it indeed is a cosmic ray point source. So speaking of cosmic rays, here's your cosmic ray report. We're going to start as far south as we can get, DOMB Antarctica, to see an interesting flatlined. Actually, it's a slight uptick there in cosmic ray flux at DOMB Antarctica. DOMC Antarctica, showing a similar graph here and a similar slight uptick over the past 30 days in cosmic ray flux. Let's go way up north to the land of Finland. There's Oulu, also showing a tiny uptick in cosmic ray flux on a 30-day scale. So that's pretty interesting. I would also note here, if you're not aware of this, folks, cosmic ray flux is inversely proportional to solar activity. When we see high cosmic ray flux, we see a solar minimum. When we see low cosmic ray flux, we see a solar maximum. And of course, the most significant solar maximum we've seen in the history here is right around 1991 there, when we also saw the lowest cosmic ray flux in history. So that's Oulu. We'll also take a look at Mexico City here. There is Mexico City. Mexico City here, a slight uptick there over the past 30 days at Mexico City as well. So we're seeing a pattern develop here, a slight uptick in cosmic ray flux over the past 30 days. What about Athens, Greece? We've got some erroneous data there. Let's just ignore that one and go back up to Apatity and Barentsburg. So here are Apatity and Barentsburg. Let's see. Apatity over the past 30 days is flat. And Barentsburg has a bunch of, oh, there we go. Barentsburg is down. So most of our cosmic ray monitors here are showing a slight uptick in cosmic ray flux over the past 30 days. It's very minor. But don't you find it interesting that we've seen so much solar activity and such high, increases in cosmic ray flux? Anyway, here's our GOES X-ray flux here. Now we're looking at solar flares. Not to be confused with coronal mass ejections. Solar flares are photons. Coronal mass ejections are protons. Think of the difference between coronal mass ejections and solar flares as a fan versus a flashlight, right? So a flashlight emits photons. Really high-frequency photons are called X-rays. Turn on a fan. The wind blowing from the fan, that's blowing protons. Protons versus photons. It's important to understand in the realm of astrophysics. Don't get coronal mass ejections and solar flares confused. Solar flares are photons. Coronal mass ejections are protons, primarily hydrogen nuclei, and then some helium nuclei, electrons, and some other heavier elements. Anyway, that's the GOES X-ray flux over the past 3 days, and frankly, all of these sunspots are underperforming. So again, don't be surprised to see an X-class flare, relativistic particles, radio blackouts caused by those solar flares as the D layer of the ionosphere gets modulated from that incoming radiation. Here's the past 24 hours from SDO and 94 angstroms. One of the best wavelengths to view solar flares. We did see some M-class intensifications in the past 24 hours. We'll also show you 131 angstroms. Again, the two places to watch, folks, are the northwestern limb and this new sunspot. We've also added 171 angstroms to the 131 angstroms for a little extended magnetic feature highlighting there. And next we'll get into what's going on overhead. So skyandtelescope.org has a great star chart. If you haven't checked it out, head to skyandtelescope.org. This is what's going on now over Lehigh Valley. We've got Mercury rising ahead of the sun. Then we've also got Saturn quite close to the sun there. Mercury, Saturn, the sun, and the moon all overhead at the same time over Lehigh Valley, Pennsylvania, where we are located. Next, our solar system forecast. By the way, Earth is at opposition, or is it conjunction, with Saturn at the moment? Anyway, here's where things are. We'll advance this 1 week to show you the forecast for the solar system. That's where things will be in a week. It looks like a new moon on the 20th. Keep in mind, folks, this imagery is not to scale. Next, we'll look at some coronagraphs. There is yesterday's coronagraph imagery from George Mason University. Here's today's imagery, another 39 frames. And there were some minor coronal mass ejections here happening. Let's take a look at the view from Stereo A and Soho Lasco C3. So Stereo A trails the Earth orbitally speaking, sees space weather a little bit ahead of Earth. From Stereo A's perspective, Earth would be off in the direction of that arrow. So we do see a far side coronal mass ejection there. No Earth side coronal mass ejections. The coast is clear, although there is some coronal hole high-speed wind out there likely showing up in about 3 days. It'll probably be fairly minor as that coronal hole is not super well defined. But you can expect to see some slight intensifications of the solar wind parameters by the 16th. Early in the day on the 16th, maybe even late in the day on the 15th, you might see a density spike. Let's take a look at the last 24 hours here from some composite imagery. Again, those CMEs are not earthly directed. And that, I believe that is Saturn right there on the Soho Lasco C3. Here's a little closer view. And how about an even closer view? And while we're talking about coronal mass ejections, why not take a look at filaments? Since they can eject without even seeing a solar flare, here's a great view of solar filaments from Cerro Tololo's ground-based solar observatory, Cerro Tololo, Chile. So we've got the Hulk Hogan filament. That's this one here. It's now becoming a prominence as it hangs off the limb. We've also got the Patrick Stewart filament right here. And wow, that is quite a lot of filaments indeed. Remember, we don't need to see solar flares to see filaments erupt. Coronal mass ejections don't require sunspots or solar flares. These are all separate phenomenon, which should be noted by your favorite YouTube channels, especially if they have no idea what they're talking about. Anyway, that is a lot of filaments, so I would say the next one that really needs a name is this one up here, because it's very large, and it's also becoming a prominence. And so, as a result, you are invited to join us on Twitter in order to name that filament. Thanks, Christine, for naming this one the Patrick Stewart. You're invited to name this one. And also maybe some of these down here. There are plenty to name, so name filaments after your favorite living people or maybe even your least favorite living people. And by the way, if you'd like to try out the very popular free samples of our Hemp Lucid gummies, you can find that on the Twitter page as well. So we're all over the internet at Smash-O-Mash. By the way, those free gummies don't require a credit card or any costs for shipping, so check those out. There are gummies for focus, for stress, for sleep, and more. You can find links on the homepage as well as below the video. Smashomash.com is the homepage, so visit us on the interwebs, help us out with clicks. Join us on our Discord chat. There's a permanent invite link right there. That's this symbol right there. That's Discord. That is to our Discord server. By the way, there are live streams coming soon. We will be doing some Twitter Spaces live streams, maybe even Facebook, so make sure you follow us on the various different social medias and let us know in the comments what your favorite social media site is, or perhaps your least favorite social media. Once again, links to the Hemp Lucid shop as well. Hemp Lucid products are fantastic, and you can get them for all different types of purposes, whether it's CBD lip balm or CBD body balm, or perhaps the most popular, the water-soluble CBD tincture. Less filling, tastes great. Solutions for sleep, focus, immune response, stress, and more. So check that out. Thanks to everybody who has Hemp Lucid. It's quite nice. Anyway, here's the past 24 hours from STO 171 angstroms. Our house favorite wavelength. As we come back to basics, this is what we really wanted to look at when we first started covering space weather. And let's take a look at some more imagery here from the GOES 16 SUVI. So interestingly enough, the GOES 16 SUVI has some wavelengths we don't usually cover on the channel, such as 195 angstroms, 284 angstroms. Those are both ionized iron also, by the way. But they've got this thematic map, so if you're not familiar with solar features, you can bring up the thematic map. And it'll show you... surprisingly, it's not really showing coronal holes here. It's showing lots of bright regions, obviously. It's showing prominences. It's showing the Hulk Hogan prominence down here. It's showing the Patrick Stewart filament. Then you can see some limb prominences. I don't know what it all means. But anyway, the thematic map is one of the other things you can view on the GOES 16 SUVI. We normally show the 304 angstroms. And we typically stream it throughout the day on the Twitch channel when the PC is idle. So there's the past about 2.5 hours from GOES 16 SUVI. Don't forget to join us on Twitter and name that filament. Also, we're probably doing a Twitter Spaces today at some point. And by the way, if we get 50 likes on YouTube, we will. So make sure you press like, by the way, if you want to see us stream live on YouTube. These are our bonus features. As far as charging hazards go, satellites have clear sailing. There ain't no charging hazards. The GOES electron flux here, both making it into warning territory here. The GOES 18 just crossing the threshold for 1,000 particles per negative square centimeter. Yeah, the electron flux here making it into warning levels. So there is the NOAA forecast for relativistic electrons. Expecting levels similar to yesterday. No argument from me there. I would tend to agree with that. And we are expecting a dip in this in a couple of days when the coronal hole wind stream shows up. Here's the one-year graph to put the relativistic electrons in context. They are measured at the F layer of the ionosphere using radiography from the geosynchronous orbits of the GOES 16 and GOES 18. So let's take a look at that layer of the atmosphere. The F layer, the bridge between Earth and space, expressed in vibrational frequency, courtesy of Australian Government Bureau of Meteorology. This imagery is fantastic at showing the location of the South Atlantic anomaly, also the South African anomaly, which is really more like the equatorial African anomaly at this point. It used to be way down here, and now it's way up here. We'll also show the anomalygram. This is anomaly in megahertz from a 30-day median. Here's the latest image. That's 1400 Universal Time. Make that 1300 Universal Time. Pardon our lateness. Coming at you a little bit later than normal for a Monday today. We'll also take a look at the total electron content. it shows the free electrons between your GPS satellite and your handset. We are seeing huge GPS errors here again. So for the last couple of months, we've been seeing very anomalous total electron contents. And I mean, you can expect major GPS errors all around the world here, even at nighttime. So that's the total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. Those are the most likely places for GPS errors, and you can expect a lot of them. Use your Wi-Fi location accuracy to help navigate. Closing out the space weather portion of the video here before we move to meteorology with the latest colorized magnetogram and the latest solar intensitygram. So first, let's take a look at these setting groups before they set. Those are beta, gamma, delta class groups. There are the fields and the umbrae. And this new group, definitely want to take a look at that. Here's that newly formed sunspot group. That'll get a name today. That is certainly beta, gamma, delta class as well. Also, this group down here exhibiting some activity recently. There's a brief look at the fields of that. That sunspot's larger than planet Earth. And that's certainly beta gamma class. It has been showing some brightening recently, so I figured we would show that briefly. Here's the full disk rock back. And before we get into meteorology, take a moment to press like and subscribe. If you press the like button, the likelihood of us actually streaming live today goes up. Because if we see 50 likes by the end of today's calendar date, we'll stream live on YouTube. Otherwise, we'll be elsewhere, probably on Twitter Spaces, possibly even a Facebook stream. Maybe we'll stream everywhere. Who knows? So make sure you press that like button. If we get to if we get to 50 likes before midnight Eastern Time, we will do a live stream. Thanks to our YouTube subscribers for tolerating the pathetic and putrid censorship on the big tech scamware platform. You know, the barely functional software. Junk. You know, it's still crap. And it's still deathware. So let's get to meteorology here to wrap up this video. So, we're looking at sea surface temperature anomaly and surface winds at the moment, and it's pretty cold in the Indian Ocean. It's pretty warm in the Southern Ocean, south of the Indian Ocean. The Atlantic here, at least the southern portion of it, is mostly anomalously warm, but only slightly. Pretty average there. And the northern bit has got quite a lot of pools of anomalously warm and cool water. East coast of the U.S. kind of cold at the moment. Southern Atlantic, or Southern Ocean, south of the Atlantic here, anomalously warm on the east side, and the Southern Pacific anomalously cold on the west side of the Drake Passage. Equatorial Pacific Ocean, very cold, and it's been for a long, long time. Northern Pacific here, mostly anomalously warm until you get up to Kamchatka and around Alaska and so on. Anyway, let's get to our regularly scheduled meteorology segment to look at surface winds of the eastern world. There you go. Those are the surface winds of this side of the planet. A strong low here still hanging out south of the Aleutians. Here are the jet streams of the east, jet streams of the west, depicted here. Surface winds of the western world depicted here. You can see that low here now off the coast of New Jersey. Surface winds of the central world, like Europe, Africa, and the Middle East, shown here, and these are the jet streams of this side of the planet. Once again, shout out to our viewers from all around the world. Thanks for tuning into the videos. And congratulations on realizing the channel exists. Now we're looking at clouds and fog over the Americas. We're using 3.9 nanometer radiation. It's part of the infrared spectrum of electromagnetic radiation. Those clouds and fog emit radiation. The satellite picks them up, and then we see them projected onto a spherical globe as we ride croissant Earth Let's take a look at our weather.gov map as we get closer and closer to the U.S. This is what's going on in the U.S. at the moment. We've got a bunch of weather warnings there. If your location's lit, click your location. We've scrolled down so you can see the key. Looks like some great surf around Hawaii once again. Let's take a look at some forecasts. So first, our accumulated positive snow depth change in inches forecast for the next 72 hours. And quite a lot of snow here coming to the western portion of the country, making it basically right up to the banks of the Mississippi and not much beyond. So west of the Mississippi there, lots of snow, especially for the Rockies. All the hot air coming out of this state is not going to stop the whole state from being blanketed by significant snowfall. Again, it's a GFS 72-hour positive snow depth change forecast in inches. We'll also show the GFS pressure and precipitation forecast. We've got a low here about to form over northern Texas and then move up toward the Great Lakes. And we'll also show temperature anomaly forecast since we've got anomalously warm temperatures in the east and anomalously cold temperatures in the west. That's your GFS 72-hour temperature anomaly forecast in degrees Celsius. And let's blast through the rest of this info and get this video onto your screen. So next we're looking at windy.com's pressure maps. And this might look weird, but it's actually not that low of a pressure, interestingly enough. Can I get a probe? No, not an anal probe. Can I get a pressure reading? I guess not. Witty.com. It's been a little glitchy the past couple of days. They got a great mobile app. Maybe it'll work better than it does in our Brave browser. Yes, we're using Brave browser at the moment for these videos. Next, your lightning mapper. Some lightning here north of the Caribbean and off the east coast of the U.S. Here's a real-time lightning map from lightningmaps.org. Give it a minute to connect. Mike says he wants to see all the tabs. Well, they're not all visible, but there are like 80 of them. Anyway, that's our Blitzortung-powered lightningmaps.org map. And I just want to bring up something here that you may not be aware of. This map does not cover everything because there are not stations everywhere. So if we actually bring up this, if we click on detailed, it'll actually show us where the stations are located. Again, because we don't have stations everywhere, so it will not pick up all the lightning, just so you are aware of that. So if you are using it to detect lightning in your location, make sure there are sensors there. Otherwise, you will not see the lightning, and then you'll say, it doesn't work, or NASA's hiding lightning, or something like that. Or, it wasn't lightning, it was a directed energy weapon. All right, so we're closing things out here. Next is U.S. Doppler radar. We've got some snow there in southern Alaska. Let's focus on the lower 48 and close this mother out. Come on, then. There we go. Now it's animated. Here is shortwave radiation over the U.S. You can see that low off the coast of New Jersey, making its way to the northeast. And here is the water vapor map. A lot of moisture there hanging out over the Montana-Canadian border. Here's your recap. U.S. Doppler radar. Shortwave radiation showing clouds and fog. And let's don't forget the water vapor. It'll really help you forecast the weather, especially if you understand atmospheric physics. So thanks for tuning into the Smash News Network, least busted name in news. Make sure you follow us on social media because there's probably some live content coming today. Let me start that over again. Make sure you follow us on social media because there's likely some live content coming today. So anyway, we'll see you soon. In the meantime, I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.